have. Like the online one.
The corrections.
I just gave it to you because I had it printed.
Okay. So we're going to talk today then about these hydrates. And so I want to do the notes for these, and then we'll get into any of the material that you have that you're missing, and we can talk about those. I just want to make sure that we have enough time for discussion today. So, all right, so what a hydrate is it is a molecule, and in that molecule we have essentially water that's trapped around it. Okay, so it's kind of like almost like a Velcro in a way. I mean, it's not, but I'm just trying to use that as an analogy, where we've got a molecule here, and we can have like water kind of stuck to it. Okay, so it's a solid in which water molecules are trapped. These water molecules then become part of the crystal, and it's called water of hydration. Okay, the hydrate then is the compound that has that specific number of water molecules around it. If the molecule has the water driven off, so we heat the thing and the water comes off of it, then that's called an anhydrate. So anhydrate form would be without water. So we can heat this hydrate, the water comes off of it, and then you're left with the anhydrate behind. Okay? So the number of water molecules associated with each formula unit is written with a dot in between. So for example, copper sulfate dot 5 H2O. We would say pentahydrate here. So the way we would call this is copper sulfate, actually copper 2 sulfate, pentahydrate. Penta is the 5. These are the same prefixes that we used back when we were doing covalent compounds. Okay, so mass of the water must be included in your molar mass calculations. And compounds can be found with a variety of water molecules. So some of them have 2, some of them have 7. Epsom salt, for example, it has 7. So if you've ever used Epsom salt, like to soak tired, sore muscles or anything like that, people will use it for a foot soak, that sort of thing. That has 7 water molecules with it. Okay. So in order to determine the formula for one of these hydrates, to analyze it, the water has to be driven off, and we drive it off by heating it. And then you can find the final mass of that hydrate before the heating and then after it, and then that determines how much water was lost. So calculate the water by subtracting the beginning mass from the ending, and the difference is how much water there was. Okay? That make sense? All right, good. There you go. All right. So if a sample is determined to have the following percent comp, what formula and name for the hydrate? Okay, so we already know you guys should be able to name this. What is this? Anybody recognize that guy right away? Yep, that's magnesium sulfate. Good. Now we need to figure out what prefix we're going to put next. So we're going to put some prefix here with how many water molecules we have with it. We've got to figure out what that prefix is going to be. We're going to use math to do that. And then we'll say hydrate. So this might be pentahydrate, heptahydrate, hexahydrate, dihydrate. So we got to figure that out using our math. Okay. So this is done the same way pretty much that we did our empirical formulas yesterday. So when we do this, if we're given percentages, we're going to assume that we have a 100-gram sample and turn these percents into grams. Okay, so that's step 1 and 2. Then we're going to figure out how many moles of this material we have. So we've got 48.8 grams of magnesium sulfate. I'm going to turn that into moles. So I've got to put grams into moles. This is 1 gram. I get this value off the periodic table for magnesium and for the sulfate. So magnesium is 24.3. I've got a sulfur, which is 32.1, and 4 oxygens. So that's 120.4 grams for every 1 mole. Oops. 48.8 divided by 120. So that is 0.405. Then I turn my water into moles. So 51.2 51.2 divided by 18, and I end up with 2.84. Now, you should always have this value either being equal to or larger than this value. Because remember, this is a molecule of this with a certain amount of water attached to it. So you have to have, if it's in a 1-to-1 ratio, then that means 1 mole of water attached to 1 mole of this. But it can't be this can't be bigger than this value. Or if it is, it's just a fractional rounding kind of amount, okay? But it's got to be, this one should always be equal to or bigger than this one, okay? So that was step 3, I believe. Step 4 is to divide by the lowest mole value. So I'm going to divide by 0.405 here, which equals 1. And I'm going to divide by 0.405 here, which equals, I think it's 7. Yep, 7. Okay. So that is 7. So that means that for every one of these, I have 7 waters attached to it. So this is going to be, we have to figure out the prefix for 7, which is hepta. So magnesium sulfate heptahydrate. And the way we write the formula for that would be MgSO4. We put a dot here, 7H2O. And you've seen these things out there. Have you seen these things in your, like, sometimes you'll get them in shoes, sometimes you'll get them in coats, but they come and they say silica gel, do not eat, okay? This is a hydrate. It's an anhydrous when they put it in there. And then they put it in there so that it can soak up water, any moisture in the atmosphere, which would possibly lead to mold growth and that sort of thing in transport. So that's why they put those in there. Another place that you'll see this is diapers. So if you take a baby diaper and kind of pat the inside of it where it would be up against the skin, you'll see this kind of powder come out of it. That powder is an anhydrous form. So when the kid pees on it, it soaks up that water and wicks it away from the skin. And so that becomes part of that molecule. But it's an anhydrous form originally, and then it soaks that up. And over the years, they've gotten better at figuring that out. That's why disposable diapers are so much better now than they used to be like back in my age when I was a kid. So when I was a kid, disposable diapers, like probably a good portion of the moms didn't bother to use them because you were throwing them away and getting rid, and you would end up with all kinds of diaper rash and stuff like that because it wouldn't wick the water away any better than cloth. And then over the years, like by the time I had kids 20 some years ago, they worked pretty darn well. And now I'm sure they're even better, but who knows? Lippy's been out of the game too long, which is fine. I want to get back in that game. All right, so anhydrous means without water, okay? Compounds can, like I said, they can be used as these drying agents. So examples, there's baby diapers, these things that you get here. There's lots of other ones as well. And they'll keep them free of water because if you get water and there's any kind of mold spores or anything like that, then those mold spores produce and reproduce and ruin whatever thing they're trying to whatever thing you have, you know. They also have, what is it called? I don't remember the name of it. I used to get it when we would go down to Mexico to take down there because it was so humid in the rooms and stuff, even with the air conditioners. I don't even remember what it's called. Diaper, I think is what it's called. Yeah, so you can get stuff like this, and I'm not purporting a specific thing, but this is just the name brand that I know of. I'm sure they sell other ones, but you can get these in like the cleaning areas at different stores, Woodman's, Target, places like that. And these things will soak up their anhydrous form, and then when they come in contact with moisture, it soaks up the moisture in the air. So sometimes you'll put this like in a closet. I used to take this when we checked baggage. I would take this down to Mexico and put it in our closet that was down there to keep our clothes, because otherwise they get kind of humid and feel kind of clammy when you try to put them on. Now that we don't check bags, they're hard to get through custom or through the TSA. So I don't take them down anymore. We just suffer. But I would always take this down when we would go to Mexico to kind of soak up some of that moisture. So this is another example of the type of thing that you would use to try to reduce that moisture. Okay. Getting back to the notes. Probably didn't care too much about that. Anyway, practical uses of it. Determine the mass percent of anhydrous sodium carbonate in water and sodium carbonate decahydrate. So deca means how many? 10. Okay. So our formula for this would be Na2CO3 dot 10 H2O. Okay. So they want to know the mass percent of the sodium carbonate. So how much is this? This is your part compared to your whole. So part over whole. Figure out what the percent is. So figure out the mass of this off the periodic table and divide it by the mass of this whole thing.
Did you want the math of just like the first part of it?
Yep, that's your top number.
Well, why wouldn't you do the second part? Well, how do you know to do the first part?
Because they said the percent mass of the anhydrous form. Anhydrous is without water.
Oh, okay.
And that is the end of chapter 10.
So yours says chapter 10.
Huh?
Yours says chapter 11.
I know.
I was just wondering.
It's actually chapter 10. So many moons ago, many moons ago, we got a new book. It's not new anymore. But I just keep using the same notes. I revamp them every year, but sometimes I forget to change things. Just say, oh, this says chapter 10. Okay, I did okay on here at least. So yeah, sometimes I forget to revamp things on worksheets, and so you get outdated chapter numbers. It's not like you've looked at a book in ages anyway, but at any rate, this ends our chapter on moles. So.
Would you be able to go up to the top so I missed something at the very top? Thank you.
So, game plan. You're going to finish your Hydrates worksheet, which I would say is 10.5. Then tomorrow, you're going to work on your review while you're gone. That's going to be on your off day. On Friday, then, you guys will do your lab. And then Monday, we will go over the review. There'll be a video on that. And then Tuesday, you have your test. Okay? Questions? All right. So I'm going to call up the answer keys for the 10.4 worksheet you were supposed to have done for homework last night. I will go over and get grades in a few minutes after you check your answers. So these were the notes, and then here's the homework you guys were supposed to have done last night. Are these corrections, or are these? Is this
No, that was the original one, but
okay.
I never got a chance to hand it in to you because I had it on paper.
Okay.
So I kept forgetting.
So here is the answers for 10. Did you do this?
I was able to complete some of it.
Okay. You're good. Let me know when you're ready to go. There's the next couple. And give me a thumbs up when you're ready to go after this one. Good. And then you weren't supposed to do 10 or 11. You should be able to do 10 and 11 now, though. So. So I'm going to, just at the end of the video, I'll give you your little, you'll be able to pause it if you want to go to the very end of the video and see what the answers are for these when you're able to do these now if you're interested in doing that. Okay. Stop recording.